What's up, Pre-Algebra? We're going to talk about adding and subtracting negatives and decimals and all that good stuff. The sum of two rational numbers is negative 18. What are rational numbers again? Well, here's a rational number, a over b, where b cannot be 0. So 3/4 rational, negative 3/4 rational, 7. That's technically rational because it could be written 7 over 1. It's just that this guy right here cannot be 0. Okay? So over here, the sum of two rational numbers, it equals negative 18. And it says one of the numbers is negative 9 and 2/3. What's the other number? Okay. It just wants you to think. So here's what we know. We know that blue number, x, is going to be negative, right? And if you're thinking, what exactly would I know that's negative? Let's look at a number line real quick. Over here is negative 18. This is where we end up. Let's put a star there. Where we begin, I guess you could say, is at negative 9 and 2/3, right? So we can kind of figure this out. We'd have to go another certain distance in order to reach 18. Well, you know what? If I actually was asking you to figure this out using the number line, here's what you'd do. Here's one thing you could do, I should say. If you were to travel another 1/3 in the negative direction, how far would you be at that point? You would be at negative 10, right? And then how far do you need to go to get to negative 18? You just need to go negative 8. So guess what? We just figured out what x is. X equals negative 8 and 1/3. So this is kind of the logic that we're going for here, all right? That when you're adding and subtracting, when you subtract, you're going in the negative direction. When you are adding, you are going in the positive direction, okay? So let's check out this next one. Tell whether the sign of the expression, if you're like, what's a sign? That's a sign, okay? That's a sign. Tell whether or not it's negative or positive. Okay, well, just like this one up here, if we begin at negative 6 and then go in the negative direction, dude, we're going to land on the negative part of the number line. Tell us why. Well, I did. I did, but maybe you're like, I don't know how I do that. You could explain it by using a number line, right? Let's do that one more time. So we started here at negative 6 1/4, and if we were to move in the negative direction, 1, 2, and then a little bit, which would be negative 7/8, that's where we would end up, right here at a negative number. It didn't want actual answers, right? So there you go. Next, find the distance between these numbers. Hint, 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 distance is always positive. So the distance between these two, all right? So I'm at 7. Oh no, 6, 7. We just went positive 1. We just went positive 2. We've now gone positive 3. And where are we at when we've gone to positive 3? We're at negative 4. So now we just have to go another 1/2 in the positive direction. Okay? And in fact, maybe if this is confusing you, here's what we did. We went plus 1, plus 1, plus 1 for a total of plus 3, right? So what is the distance that we covered? 3.5, okay? And this whole thing about distance always being positive, that's a throwback a little bit to the absolute value. So like the absolute value of 3.5 is still 3.5, okay? Use reasoning to fill in the blank of greater than, less than, or equal to no actual answers. Okay, so if I had, let's change to the little highlighter thing. Highlighter. If I had negative 1/3 plus 3/4 again, my brain going back to our number line. Here's 0, here's negative 1/3, here's, and then what we're doing is we're going in the positive direction 3/4. Okay, well, this number is bigger than this number. So our answer here is going to be positive. Now, I haven't given this yet. I haven't given an actual answer, so we're safe so far. Let's take a look at this. All right, so here's negative 1/3, just like we had here, right? Here is positive 3/4, just like we had here. They're being combined the same exact way. It's just that they start like this on the number line. Boom, hang on. There's 0, there's 3/4, and then they're going to go in the negative direction 1/3. So guess what? This is on the positive side. This is on the positive side. We're going to have a positive result. These two guys are equal, okay? This is called the commutative property, by the way. And that if you had 2 plus 3, that's 5, but so is 3 plus 2. But then what if you had negative 2 plus 3? That's 1. And then now if you flip them like this, plus negative 2, that's still 1. The commutative property lets you flip the numbers around, and it works for addition and technically subtraction. Okay? Check this one out. We have negative 1/2 and negative 1/2. If you don't read it like that, that's okay. But here's what's going on. You're at 0, or I'm sorry, there's 0. You're at negative 1/2. And then they say, hey, let's go negative by 1/2. We just went to negative 1, okay? So that's what that one's like. Let's take a look over here. Oh, look, negative 1/2 again. And then wait a second, this is a positive 1/2. So let's number line this. There's 0. You are at negative 1/2. And then you were going to go in the positive direction 1/2. Guess what? You're at 0. So they didn't want real answers, right? But this is what we have, negative 1 and 0. What's the sign going to be? Is it greater than, less than, equal to? It is negative 1 is less than 0. That is our answer right here. Now let's evaluate some expressions. Some of you might think we just did some of this stuff. Well, great. Let's see how you do. Negative 2/15 minus 1/3. Okay, so like I said previously, I try and think of it like this. I'm like, okay, here's 0. I am beginning at negative 2/15. And according to this, I am about to go negative 1/3. So I'm definitely going to have a negative answer, right? So here's what I'm going to do with that. 2/15 plus 1/3 is going to equal some negative number, okay? Let's zoom in here and get our common denominator, multiply by 5/5. We have 2/15 plus 5/15 equals 7/15. I am here. That is 7/15. But what did we say? What did we say? It was negative. So throw that negative in front of there. Throw that negative in front of there. That's the answer, okay? All right, here we go. We have 5 7/9 plus the absolute value of negative 3 2/3. So I would say, hey, you definitely, thinking in terms of the number line would be very helpful. But not really, because check this out. Here's where 5 7/9 is. And then the absolute value is trying to say, hey, listen, we're going to travel an exact distance of 3 2/3. And we're going to be traveling a positive version of that. So positive direction, we're going to hop this way 3 2/3 as much. When would this be negative? As if there was a negative out front already, but there's not. So this is a pretty straightforward just adding two fractions. We now need to do common denominators then. So this guy has a pretty simple common denominator. We're going to have 5 and 7/9 plus 3 and 6/3. Nope. Plus 3 and 6/9. And we end up getting 8 and 13/9, which, by the way, that kind of tracks, right? Because 5 plus 3 is 8, and then we're going to be adding some more, right? So we end up getting 9 and 4/9, okay? And if you want that as an improper fraction, then let me remind you how to do that thing. How you do that thing is you're going to here, we'll do it with this. We're going to multiply from here to here. And we're going to add from here to here. Add. So we have 45 plus 7/9, which would be 52/9. Same thing here. We're going to multiply here, add here. 9 times 3 is 27 plus 6 is 33/9. And now you have 52/9 plus 33/9. That's 85/9, which, just by the way, is exactly 9 and 4/9. Okay? Next one. We're kind of back on that idea of what I like to do, which is say, hey, I notice that this is going to be negative. So I'm looking at this and I notice my answer is going to be negative. So instead of messing with the negatives, I make them both positive because they're combined and they will equal a negative answer. And if you're still going, what is going on? Check it out. Here's 0. Here's -7 and an 1/8. And if you don't want to write 7 and an 1/8, don't do it. Instead, just kind of round it to be 7, okay? But here it is. We started at -7-ish, and we're going to go in the negative direction. Negative direction, 8 and 5/12, or let's just call it like 8 and then some, right? So we're down here at like -15 and some change, yeah? That's why I say, what's another way we could get this? 7 plus 8 would also be 15-ish, right? A +7 and a +8. So let's do that. 7 and 1/8 plus 8 and 5/12. It's all right. I would like to do common denominators, I guess, because I know that if I multiply this by 3/3 and this by 2/2, I'm going to get 24s. So 3/24, 7 and 3/24 plus 8 and 10/24. When you add that together, you're going to get 15 and 13/24, which is your answer. Negativo 15 and 13/24. That's your answer, okay? It doesn't reduce because 13 is a prime number and it doesn't divide into 24. So starting here at -7 1/8, going in the negative direction, 18 and 5/12, you end up there. Next. All right. Some of y'all might about to lose your minds because we've got 3 numbers. And you were not really enjoying when it was like 2 minus 3 plus -4. You were hating that. Well, okay. You did that. You were a master at this now. Now let's tackle this, okay? I'm just going to do 2 at a time. There's no need to think beyond 2 at a time, okay? So we need a common denominator. Let's multiply this by 3/3. And we get 7/12 plus 9/12. That is 16/12. Plus, and if I wait, plus, that right there is a plus -2/3. In this situation, you can kind of proceed how you would like to as just a regular subtraction problem, because here's the number line. Here's 0, here's 16/12, and if you're like, I don't know how much that is, it's bigger than 1, right? Because 12/12 is equal to 1. So like, let's say that that's 1, right? Is this bigger than 1? No. So we're going to hop backwards and land somewhere positive, right? So here we go. I'm going to multiply this by 4 over 4. And what's going to happen is I get 16 twelfths minus 8 twelfths. And that leaves me with 8 twelfths. That's fun. 6 and 8 is 8. And you can divide both of these by 4 to get 2/3. So maybe you didn't see that coming. I don't know. But our final answer, when we add all these together, is 2/3. 2/3. Here's another one where we are starting out. Here's 0. We're at negative 8.5, which is what that is, right? And we're going to go in the positive direction. 1 1/4. Okay? Well, pretty clearly, again, our answer is going to be negative. So here's what I'm going to do. I'm going to go with 8 1/2 minus 1 1/4. Okay? That's going to land me right here. If you're a little confused on why are we switching these signs, think of this number line, okay? Think of what would happen if you had 8.5 and then you're going towards 0. Towards 0 would be a negative direction, right? There's this negative right here. I know that might be a little tricky, but this is an approach, okay? So we need a common denominator. Let's multiply by 2 over 2, and we get 8 2/4 minus 1 1/4. And what we end up getting is 7 1/4. Is that it, though? No, it needs to be negative. Negative 7 1/4 is our answer. Negative 3/4 plus 5/6 plus 7/6. All right, what would you like to do? You should focus on 2 at a time. You know what I'm going to do? I'll focus on these 2 because they already have a common denominator. And that is just, boom, we're at 12/6. And did you know that this is just 2? And if you're thinking, well, how am I supposed to know all this stuff? I'm thinking that you guys you need to be looking for things that work easily together, right? That's just kind of my recommendation. So if we're at 2 and we're about to go negative 3/4, well, there's 1. 3/4 is not quite 1. In fact, we can really kind of do this math in our head. If we have 2 and we go down 3/4, our answer is 1 1/4, right? But if you don't see it, then here's what we're going to do. We're going to take this minus 3/4, this negative 3/4, and put it right here. Minus 3/4. Uh-oh, they don't have a common denominator. We could find one, okay? Here's the other thing. Since this is just 2 over 1, I mean, we could do it like that, and then we could multiply him by 4 over 4. I mean, really, the options, you have lots of options. There's lots of different ways to make this thing happen. So if I've confused you with this one, tell me in person. We can go over it again and again until you feel like you get it. But check it out. 8/4 minus 3/4 is 5/4. Wait a minute. That's not 1 1/4. Yes. Yes, it is. Those are the exact same answers. Find the difference. Show your thinking. Okay? So really, here's my thinking. I'm at 3/7. That's bigger than 0. I'm going in the negative direction. 10/7. Well, if we were to like really break this number line down, here's 1/7, 2/7, 3/7. So to go 10/7 this direction is negative 1/7, negative 2/7, negative 3/7. Let's see. We've gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be negative 4/7. Oh, slide over. Negative 5/7, negative 6/7, negative, Negative 7/7. Oh my goodness, that is negative 7/7, which is negative 1. Maybe you're like, Mr. Math, I didn't need to show my thinking on that. I'm just trying to be helpful and show some thinking that could happen, right? But 3/7 minus 10/7 is negative 7/7, which is negative 1. If this is all the thinking you showed, cool. Number 2, first thing I'm going to show is I know that a negative like this is adding, okay? If they are immediately next to each other like this, then we're going to add 7 plus 13 is 20/12 like that. And then we could reduce this. I'm going to divide that by 2. I'm going to divide that by 2, and I get 10/6. I could have divided it by 4, but I'm going to divide by 2 again, and I get 5/3, which is 1 2/3. Okay? All right, we're at negative 1/3. So here's 0, we're at negative 1/3. 1/3, like that. And this negative and this negative are right immediately next to each other. So we're going to be adding 9/4. 9/4 is bigger than 1 because 4/4 is exactly 1. Okay? So we're going to be jumping way over here on the positive side. And if you're like, wait, why is it doing that? Because here's how I'm going to do this problem. 9/4 minus 1/3. Okay? If I were at 9/4 and went negative 1/3, I would end up at the same location as if I had gone from negative 1/3 and added 9/4. Okay? So, and if you're like, that seems brand new information to me, I did it over here. I've done it on the previous video. I've done it. Okay? I'm trying to say that this is an approach that you could take. We're going to multiply this by 3/3, by 4/4. We get 27/12 minus 4/12. Oh, and by the way, I forgot to mention, and I've written this down on all the others, it's pretty clear to us that our answer is going to be positive, right? So that's one reason why we're taking this approach, is because it's going to be positive. So 27 minus 4 is 23/12. And that's it as far as an improper fraction. As far as a mixed number, it is 1 11/12. Negative 3.5 minus 1 5/6. Okay, here's 0. Here's negative 3.5. And then we are going in the negative direction, 1 5/6. So let's just say we're going like 1. And then if this was 2, we're going to be going like right here. So our answer is definitely going to be negative, right? So here's how I'm going to approach this. I'm going to say 3.5 plus 1 5/6. Why? Again, if let's say I was at 3.5 over here and I went over like this, 1 5/6, that would be like doing this, okay? And just our final answer needs to be negative. Yeah? Yeah. All right. So we can multiply this by 3/3 to get a denominator, a common denominator of 6. So we have 3 3/6 plus 1 5/6. That is going to be 4 8/6, which is really 5 2/6. Which is 5 1/3. But are we missing something? Heck yeah, we are. We're missing the fact that it's negative, right? That we were here to begin with. We really were at negative 3.5. And then we went further negative. So our answer needs to be negative like this. And if you would like an improper fraction version of this, it's negative 16/3. Oh, I meant to do a giant circle. It did not happen. That's our answers. Next, negative 12.41. Wait a second. When did we ever start to do decimals? Technically speaking, we could have been doing decimals on a lot of this stuff, but this is just, all right, let's see if you can practice. Let's see if you can apply some of the whole negative things and with this. So, all right, we start at, here's 0. We start at negative 12.41. And then what's happening is we have a negative like this. That makes a positive. When they are right immediately next to each other, they're positive like that. So we're going to go nearly 10, but that's still not enough, right, to be positive. So we still have a negative answer. So here's what I'm going to do. This may or may not surprise you. 12.4, let's write that a little bit bigger because I write big. 12.41 minus 9.95. So imagine that we began way over here at 12.41 and we were to go backwards 9.95. That would be the similar idea, okay? It's just that now we know that our final answer needs to be negative because of that. And then this just becomes a little bit simpler to solve. So like this is 11, 14, but we're going to borrow from that to make it 13. This is 11, this is 6, 4, 2, negative 2.46. All right, we got 2 minus 8.25. And I'm going to continue doing this thing where I'm like, hey, we're at 2, and we are about to go in the negative direction, 8.25. Well, if we were to go just 2, we'd be at 0, right? If we were to go just 2, we'd be at 0. So we're going to go another 6.25. And guys, I got to tell you, that's the answer, is it's just negative 6.25. But if you're not seeing this in your mind when you do this, then again, our answer is definitely going to be negative. So here's what I would do. 8.25 minus 2. And then this is a little tricky. You got to remember that these need to be zeros right here. So 8 minus 2 is 6, 2, 5, like that. So, and then remember, our answer will be negative. There it's negative. Evaluate the expression. Think you may be able to use the commutative property to rearrange. And it's like, what's the commutative property? A minute ago, we talked about the commutative property that these could kind of be swapped around, right? So why would you ever want to swap around? Well, because you could make a little less work for yourself in some cases. For example, 2/5 and this guy right here are common denominators, so I could go ahead and combine them if I really wanted to. 2/5 plus 3/5 is 5/5, which is, guess what? 1 whole. So we could do 5/5 minus 7/10, or we could do 5/5 minus 7, I'm sorry, or we could do 1 minus 7/10, which would be way easy because 1 is equal to 10/10. There are 10 pieces that make up a whole. And how do I know that? Because that's them telling us how many pieces there are. So 10 minus 7 is 3/10. That's the commutative property made this a little bit easier. How about this one? Oh, brother, it looks awful, but wait. We have an 1/8 right here and an 1/8 right here. Let's combine them. Negative 1 3/8, and then negative 6 7/8. Yep, we said 6, 7. That's crazy, huh? What's going to happen is we basically have 6 7/8 minus 1 3/8. How do I know this? Well, because right here it says this is positive, right? And then we are going to be subtracting 1 3/8. So this is easier than you might think. 6 minus 1 is 5. 7 minus 3 is 4. And the eighths stay the same. So we have 5 and 4/8. Did you know that that is 5 1/2? And this is, they're kind of assuming that you can do some of this math, by the way, without doing a lot of thinking. So now what we're going to do is subtract 8 1/2. Subtract 8 1/2. Okay? So what I'm seeing here is that on our number line, we are at 5.5, and we are about to subtract 8.5. Okay, well, how far is it to 0? It's roughly 5.5 to 0. So there would only, it would only be another 3 to get right there. So the answer here is just -3. Just got a couple more. Plot on a number line to show and write the distance between the two numbers. This is the absolute value of their difference. We have 6 here. We have -4 and 1/4. What's the distance? Well, there's a 0 in the middle. From here to here is 6. From here to here is 4 and 1/4. The total distance is 10 and 1/4, because 6 plus 4 and 1/4. Now we have 0, we have -3.1, we have -5.7. So this one's a little trickier because it's like, okay, well, how far is it from here to here? Okay, well, let's just count. So if we were to go a total distance of 1, we would be at -4.7. Go another total distance of 1, we're at -3.7. So then how far do we need to go to get from here to here? Now I realize my visual is a little messed up, but we just have to go a distance of 0.6. Right? To get from 0.7 to 0.1 is just a difference of 0.6, right? So now we just add that up, and our answer is 2.6 is the distance, which is the absolute value. Hey, we're done.